Okay, let's unpack this. You walk into almost any gym, anywhere, right? And you'll see athletes mixing powders into their drinks.
Oh, yeah, F everywhere.
And one of the most popular, definitely one of the most studied, is creatine. We're talking like millions using it across pretty much every sport.
Absolutely. It's huge in the sports world.
But what do we really know about it, beyond the locker room talk and maybe some old myths?
Well, that's the thing. It's widespread, sure, but what's really interesting is the sheer amount of science behind it.
Yeah.
And crucially, how much of that science actually goes way beyond just athletic performance.
Exactly. So that's our mission for this deep dive. We want to cut through all the noise, the anecdotes, maybe some outdated warnings you still hear.
Boy.
We're going straight to the source, a massive, really authoritative one, a major scientific review and position stand from the International Society of Sports Nutrition, the ISSN.
And this isn't just, one or two studies. This review, it came out in 2017, pulled together findings from over 1,000 studies. We're talking billions, literally billions of servings consumed.
Wow.
Yeah, it's a really comprehensive look. Covers everything from the basic biology up to potential medical uses. And we're going to stick only to what's in this review. Understand what creatine is, how it works, what the evidence says for performance, for health, and definitely tackle those safety questions people always ask.
Okay, let's do it. Let's jump right in. At its core, what exactly is creatine?
Okay, so it's a naturally occurring compound. Technically a non-protein amino acid. You get some from food, mainly red meat and seafood.
Makes sense.
But your body also makes it itself. Liver, kidneys mostly, using other amino acids like arginine and glycine.
So does that mean vegetarians might have lower levels naturally?
That's right. The review does mention that. Vegetarians often have lower baseline stores in their muscles compared to people who eat meat regularly.
And where does the body keep most of this creatine? Like, where is it stored?
About 95% of it. It's tucked away in your skeletal muscles.
Yeah.
The other 5% or so is in other places like the brain, testes, important tissues.
Got it. Okay, now the big question, especially for athletes, how does this stored creatine actually help with energy? How does it boost performance?
Right. This is where it gets really, really interesting. Creatine's main job is all about providing quick energy inside the muscle cell. When you supplement, you increase the total amount in the muscle. And a big chunk of that gets converted into something called phosphocreatine, or PCR. Basically, it grabs a phosphate group.
Phosphocreatine, PCR. And that helps with energy.
Yes, exactly. Think of it like a super fast charging battery backup for your muscles. Your main immediate energy currency is ATP, adenosine triphosphate.
Right, ATT. Heard of that.
When your muscles need a sudden burst of power, like for a heavy lift or a sprint, you burn through ATP really fast. The problem is you only have a tiny bit stored up.
Okay.
So during that really intense effort, you need to remake ATP almost instantly.
And that's PCR's job.
That's exactly its job. The review really highlights this system, the creatine kinase phosphocreatine system, or CKPCR system. There's an enzyme, creatine kinase, that helps PCR donate its phosphate group back to ADP. That's what's left after ATP is used, and boom, you regenerate ATP right there on the spot.
Wow, so it's like an immediate energy buffer. Keeps you going for a bit longer at peak intensity.
Precisely. It allows you to sustain that maximal effort for maybe a few crucial seconds longer than you could otherwise. The system also helps shuttle energy around within the cell, too, from where it's made to where it's actually used.
Interesting.
And the review mentions another potential perk. This system, especially in the mitochondria, the cell's power plants, might help reduce the formation of unstable molecules called reactive oxygen species. So it might have a kind of antioxidant effect, directly or indirectly.
Huh, that's fascinating. So fundamental to how our muscles work. Now, if our natural levels aren't, totally full, how does taking extra creatine actually boost those stores?
Good question. So a typical diet usually leaves your muscle creatine stores maybe 60 to 80% saturated. Supplementation aims to bump that up, increase it by another 20 to 40%.
Okay.
And the fastest way to do that, according to this review, is what's called a loading phase.
Loading phase, what does that involve?
It's usually about 0.3 grams of creatine per kilogram of your body weight per day, but you split that dose, typically taken 4 times a day, for about 5 to 7 days.
So for an average person, maybe like 5 grams 4 times a day?
Yeah, roughly. For many people, that works out to about 20 grams total per day split up for that first week. That really quickly saturates the muscles, tops off the tank, so to speak.
And then what, after that loading week?
Then you drop down to a lower maintenance dose. Usually just 3 to 5 grams per day is enough to keep those muscle stores saturated.
Just once a day?
Yep, just once a day. Though, the review notes larger athletes might need a bit more, maybe 5 to 10 grams daily, to maintain those levels.
What if someone doesn't want to do the loading phase? Can you just start with the lower dose?
You absolutely can. You could just take, say, 3 grams a day from the start. It'll still increase your muscle stores, but it'll take longer. Maybe around 28 days, the review suggests, to reach full saturation.
So the performance benefits might take longer to show up that way.
Exactly. Loading gets you there faster, but the slower approach works too, just takes more time.
Okay. Now, you hear people talk about cycling creatine, taking it for a while, then stopping, then starting again. Is that actually necessary?
The review addresses this. It mentions that after you stop taking creatine, it takes about 4 to 6 weeks for your muscle stores to return to your normal baseline levels.
Okay.
But crucially, the review states there's no evidence that taking creatine long-term suppresses your body's own natural production of creatine. So from that perspective, cycling isn't really needed. Your body doesn't forget how to make it.
Good to know. Are there any tricks to help your muscles absorb more of the creatine you take?
The review does note something here. Taking creatine along with carbohydrates, or even a mix of carbs and protein, seems to help promote greater retention of creatine in the muscle.
Interesting. Maybe taking it with a meal or a post-workout shake?
Yeah, something like that could potentially enhance uptake a bit.
All right, what about all the different kinds of creatine you see advertised? Creatine HCl, ethyl ester, buffered creatine, all these fancy names.
Yes, the different forms. The review is actually very, very clear on this point.
Oh, yeah.
It states that creatine monohydrate is by far the most studied form, and it's the form with the most robust clinical evidence showing it's effective.
So all those claims that other forms are better absorbed or more stable or cause less bloating?
According to this massive review of the evidence, those claims are essentially unfounded. There just isn't solid clinical data to back them up compared to good old creatine monohydrate.
So the advice based on the science is stick with monohydrate.
That's where the overwhelming weight of the evidence lies, yes. The review also confirms it's quite stable as a powder. It can degrade over time if you mix it in liquid, especially if the drink is acidic or warm, but
it gets absorbed well anyway.
Exactly. Once you swallow it, the absorption in your gut is very high, almost 100%, regardless of how fast it moves through.
Okay, good to know. Let's pivot to what most people are really interested in, performance. What does the science synthesized in this review say about creatine's value for athletes?
The review doesn't mince words here. It calls creatine monohydrate the most effective ergogenic nutritional supplement currently available to athletes for increasing high-intensity exercise capacity and lean body mass during training.
Wow, most effective. That's a really strong statement.
It is. And it notes this isn't just the ISSN's view. It's a consensus shared by other major sports nutrition organizations, too. It's pretty well established.
So how does that actually translate? What does an athlete feel or see?
Well, by boosting those phosphocreatine stores we talked about, you can regenerate ATP much faster during those short, intense bursts of effort.
Right.
This means you have an increased capacity for things like single sprints or repetitive sprints. You can often perform more repetitions during a maximal effort set in the gym. Basically, you can handle more high-quality work in those high-intensity intervals.
And how much of an improvement are we talking?
It varies, of course, depending on how much an individual increases their muscle PCR levels, but the review suggests performance improvements in the range of 10 to 20% for these types of activities.
That's significant, and I guess that ability to do more work in a single session adds up over time.
That's the key point for training adaptations. By increasing your capacity to perform high-quality work during your training sessions, you're applying a greater stimulus to your muscles and energy systems.
Which leads to better results long-term.
Exactly. It leads to greater adaptations over weeks and months, bigger gains in strength, more muscle mass growth, and ultimately better overall athletic performance.
Makes sense. Which specific sports or activities seem to benefit the most?
The review lists quite a few. Anything involving short, powerful bursts, really. So track sprints, swimming sprints, pursuit cycling. Also intermittent sprint sports, think soccer, basketball, American football, ice hockey.
Lots of stop and start action.
Right. It also mentions sports where buffering acidity or rapid energy resynthesis is key, like rowing or combat sports. And of course, sports where simply having more muscle mass or power is an advantage. Football again, powerlifting, bodybuilding.
What about endurance athletes? Does it help them at all?
Maybe not for the long, steady-state stuff directly, but the review notes It can even help endurance athletes by improving their ability to handle interval training sessions, which are often part of their overall plan.
Interesting. Are the benefits generally the same for men and women?
The benefits are seen in both men and women, yes. The review does mention that some studies suggest women might experience slightly less magnitude of gain in strength and muscle mass during training compared to men,
But
but
other benefits still apply.
yes, other benefits like improved sprint capacity, recovery, and all the non-performance aspects we'll get into, those generally apply across the board.
Okay, good. So, moving beyond just raw power and strength, the review talks about other ways creatine helps athletes, like recovery.
Absolutely, this is a big one. It seems to enhance recovery from intense training. For instance, taking creatine along with carbs, or carbs and protein, can actually improve glycogen replenishment in the muscles.
So, refueling the muscles faster after a hard workout.
Exactly, helping you be ready for the next session sooner.
And what about muscle damage itself? Does it help with soreness or recovery from that?
Yes, the review cites studies showing it can improve the recovery of muscle force production after exercise that causes damage.
Hmm.
It can also reduce some of the biochemical markers associated with muscle damage and inflammation, things like creatine kinase leaking into the blood or TNF-alpha.
So, potentially less soreness and faster bounce back.
That seems to be the case, helping athletes recover more effectively.
Which sounds like it could help athletes tolerate really demanding training periods.
That's the implication, yes. It might help athletes maintain performance levels during periods of intensified training, sometimes called overreaching, when they're really pushing the limits.
Okay, now we have to address the big myths. Injuries, cramping, dehydration. These things follow creatine around like a shadow. What does this massive review actually conclude?
This is where the review is exceptionally clear and really important. Based on the extensive peer-reviewed literature they analyzed, there is no scientific evidence that creatine supplementation increases the incidence of musculoskeletal injuries, muscle cramping, or dehydration.
None. Zero evidence from over 1,000 studies.
Yeah.
That seems to fly directly in the face of what a lot of people think they know.
It really does. And it goes further. The review actually highlights several studies where athletes using creatine experienced a lower incidence of these very issues compared to athletes who weren't using it.
Wait, lower. So less cramping, less heat illness?
Yes. Lower incidence of muscle cramping, heat illness or dehydration, muscle tightness, muscle strains and pulls, non-contact injuries, and even total injuries or missed practices in some studies.
That is a complete reversal of the common myth. Incredible.
It really underscores the importance of looking at the actual controlled research rather than just anecdotes.
Okay, and related to dehydration, what about exercise in the heat? Does it make things worse or?
Quite the opposite, according to the review. Creatine has osmotic properties, meaning it helps cells hold on to water. This can actually lead to a state of hyperhydration in athletes.
Hyperhydration.
Yeah, basically carrying a bit more total body water. And studies cited show this can actually reduce physiological strain during exercise in hot environments. Things like lower heart rate, lower core body temperature, lower sweat rate for the same amount of work.
So it could actually reduce the risk of heat-related illness.
That's what the evidence suggests. It seems to improve heat tolerance, not impair it. It's even been used effectively alongside glycerol in specific strategies designed to hyperhydrate athletes for heat adaptation.
Wow. Okay, myth busted. What about using creatine during injury rehab? Can it help recovery?
There's promising research in this area too. The review discusses findings suggesting creatine can help lessen the amount of muscle atrophy, muscle loss, that happens when a limb is immobilized, like in a cast.
That could be huge for recovery time.
Potentially, yes. And it might also promote better strength gains during the rehabilitation process itself, helping athletes regain muscle fiber size and peak strength more effectively.
Are the results consistent?
The review notes results are a bit mixed in some very specific patient groups, like after ACL surgery or for spinal cord injured athletes in wheelchairs. But overall, it shows definite promise for supporting recovery from various exercise-related injuries.
Okay. And the review also dives into something really fascinating and maybe less expected: neuroprotection, protecting the brain and spinal cord.
Yes, this is a really significant area highlighted in the review. Creatine appears to have neuroprotective qualities. Now, most of the studies discussed are in animal models, but the implications, especially for athletes in contact sports, are quite compelling.
What kind of protection are we talking about?
Research suggests it can help reduce the extent of damage following things like traumatic brain injury, TBI, cerebral ischemia, which is damage from lack of blood flow, like in a stroke, and even spinal cord injury in these models.
How does it do that? What's the mechanism?
It seems to work by helping maintain the energy balance within neurons, supporting mitochondrial function. Remember, the energy powerhouses. In some models, it helped reduce the size of the damaged brain area or limit the loss of gray matter.
That's incredible, especially relevant with all the concerns about concussions and head impacts in sports.
Absolutely. It's an exciting area of ongoing research with potentially huge implications.
Okay, let's broaden the scope even more. The review doesn't just stop at athletes. It explores potential medical uses, too. What stands out there?
Well, one very clear application is for rare genetic disorders, where the body can't make or transport creatine properly. These are called creatine synthesis or transport deficiencies.
Right.
For individuals with these conditions, lifelong supplementation, often at very high doses, the review mentions up to 0.8 grams per kilograms per day, which is like 56 grams for a 70-kilogram person, can significantly increase brain and muscle creatine levels.
And that helps them clinically.
Yes, it could lead to substantial improvements in clinical outcomes, especially if treatment is started early in life. And importantly, this use in vulnerable populations, including infants and children, at such high doses for long durations, provides really powerful evidence for the overall safety profile of creatine.
That is incredibly strong safety data, if it's safe at those levels for infants with medical needs.
Exactly. It tells you a lot about its fundamental tolerability. The review also touches on neurodegenerative diseases, things like muscular dystrophy, Huntington's disease, Parkinson's, ALS.
Has it shown benefits there?
The results are mixed. Large clinical trials for Parkinson's and ALS didn't show a significant clinical benefit on the main things they were measuring. However, there was some evidence it might slow down brain atrophy in Huntington's disease. And in some studies across these conditions, it did show promise for improving exercise capacity or muscle function.
But importantly, from a safety perspective.
Crucially, yes. The review emphasizes that even in these patient populations, creatine has been used safely and was well tolerated, even at high doses like 30 grams per day for up to 5 years in some trials.
Okay. What about the heart? Any potential benefits there?
Creatine and phosphocreatine are vital for heart muscle energy too. The review suggests that supplementation might offer some protection to the heart during ischemic events, periods of low blood flow, like during a heart attack. It might help reduce arrhythmias, those irregular heartbeats, or improve heart function after such an event. There's also specific mention of administering phosphocreatine itself during certain cardiac procedures, like cardioplegia during heart surgery, to protect the heart muscle. So taking creatine regularly might be beneficial for people at higher risk of heart problems.
Interesting. And then there's the whole area of healthy aging. Is creatine relevant there?
Yes, definitely. There's a growing body of evidence supporting creatine use for promoting healthier aging. The review lists a whole range of potential benefits.
Like what?
Things like potentially improving cholesterol and triglyceride levels, reducing fat accumulation in the liver, lowering homocysteine levels, which is linked to heart disease risk, also acting as an antioxidant, possibly enhancing blood sugar control in type 2 diabetes.
Wow, quite metabolic benefits.
And musculoskeletal too, increasing strength and muscle mass, which is huge for older adults, minimizing bone loss, improving functional capacity in conditions like osteoarthritis or fibromyalgia, positively influencing cognitive function, and even potentially acting as an antidepressant in some studies.
So it really helps fight off some of the common declines associated with aging, like muscle loss?
Exactly. It's particularly noted for helping to prevent or mitigate sarcopenia, that's the age-related loss of muscle mass and function, and also bone loss, especially when it's combined with resistance training.
So it's not just for young bodybuilders, it's for helping grandma stay strong and active too.
That's a great way to put it. It supports overall musculoskeletal health and seems to have these broader metabolic and even cognitive benefits that become really important as we get older.
You mentioned cognitive function specifically. The review highlights that.
It does. Supplementing with creatine can increase the amount of creatine in the brain, maybe by 5 to 15%.
And that helps out.
The review points to studies showing this can lead to reduced mental fatigue. It can improve aspects of cognitive performance, like working memory, speed of processing information.
Even under stress.
Yes, benefits have been shown even after periods of sleep deprivation, and also specifically in elderly individuals, helping maintain cognitive sharpness.
That's a benefit I think most people would not associate with a typical muscle supplement.
It really underscores that the CK-PCR energy system is fundamental, not just in muscle, but in brain tissue too. High energy demand there as well.
Fascinating. And one last area you mentioned, which was really surprising potential roles during pregnancy.
Yeah, this is really emerging research, but the review notes that the demand for creatine increases significantly during pregnancy.
Yeah.
And animal studies have suggested that if the mother supplements with creatine, it might improve survival and organ function in newborns who experience birth asphyxia. That's a dangerous lack of oxygen during birth. Human studies are apparently underway or being planned to explore if maternal creatine supplementation could benefit fetal growth, overall development, and health. It's an area with potentially massive public health implications if the benefits hold up.
Absolutely incredible. The scope here is just huge, from elite athletes to potentially protecting newborns. Okay, let's circle back hard to the question on everyone's mind. Safety. After reviewing all this, over 1,000 studies, what's the final word from this massive ISSN review on the safety of creatine monohydrate?
The bottom line, after synthesizing all that data, is remarkably straightforward. The review states unequivocally that the only consistently reported side effect in the scientific literature is weight gain.
Weight gain.
Yes, primarily due to increased water retention in the muscles when you first start taking it and saturate those stores. That's it.
And it specifically takes on those persistent myths we talked about, the cramping, dehydration, injuries.
Yes, it directly confronts them. As we discussed, it finds no evidence to support those claims. In fact, the data often points the other way, lower incidence of cramping and heat issues in creatine users in some studies. Claims of GI upset, like stomach aches. Also not supported by the evidence from well-controlled trials cited in the review.
Okay, but what about the big one, the one people always worry about? Kidney damage. Does creatine harm your kidneys?
This is a major focus, and the review addresses it head-on. Despite some old case reports, which often involve people taking multiple supplements or having pre-existing kidney problems, the overwhelming body of evidence from controlled studies is clear.
And that evidence shows.
Extensive studies, short-term high dose, long-term use for up to 5 years, studies in healthy people, in athletes, and even in clinical populations, including people with type 2 diabetes or existing kidney disease, show no compelling scientific evidence that creatine supplementation negatively affects kidney function.
So even long-term use, up to 5 years studied, and even in people who might be considered higher risk, didn't show kidney problems.
That's what the scientific consensus presented in this review indicates. The review explains that the slight increase in creatinine levels sometimes seen in blood tests of creatine users is expected. Creatinine is just a normal breakdown product of creatine metabolism. It doesn't signify kidney damage in this context.
So that blood test result needs context.
Exactly. Now, the review does prudently suggest that individuals who already have significant pre-existing kidney disease might want to consult with their physician before starting, just out of an abundance of caution. But the science itself doesn't show that creatine causes harm to healthy kidneys or worsens existing mild conditions based on the reviewed literature.
That's really important clarification. What about younger users, kids, adolescents? You often see warnings on labels saying, not for use under 18.
The review tackles this directly too. It basically states that those label warnings are generally there for legal liability reasons, not because there's scientific evidence of harm specific to younger age groups.
So the ISSN position is,
the review concludes that creatine supplementation is considered acceptable for younger athletes, provided they meet certain criteria. They should be involved in serious supervised training. They should be eating a healthy, performance-supporting diet already. They need to be educated on how to use creatine correctly. And crucially, they shouldn't exceed the recommended doses.
and under those conditions, it might even be beneficial or safer than alternatives.
Yes, the review posits exactly that. It suggests that for these young athletes, creatine could provide benefits like enhanced training adaptations and potentially even reduced injury risk. And it makes the point that it could be a significantly safer alternative to illicit, dangerous performance-enhancing drugs that some young athletes might unfortunately be tempted by.
And we already mentioned the safety data from infants and children using high doses for medical reasons.
Right. Those studies involving infants and children with genetic creatine deficiencies using very high doses safely for years further bolster the safety profile, even in the youngest populations.
And for older adults or people with other diseases.
As we covered in the medical uses section, the review consistently highlights that creatine has been used long-term again, doses up to 30 grams a day for as long as 5 years studied across a wide range of patient populations, from infants to the elderly, including those with various neurodegenerative diseases or metabolic conditions. And the literature reviewed reported no significant clinical risks or adverse events associated with creatine use in these groups.
So, wrapping up the safety discussion. The overwhelming scientific consensus presented in this massive 2017 ISSN review is that creatine monohydrate, when used appropriately, is safe, it's effective, and it's remarkably well tolerated across a huge range of people, different ages, different health statuses.
That is the clear, unambiguous, and strong conclusion drawn from the vast body of scientific research synthesized in this comprehensive position stand.
Okay, let's crystallize this. The review finishes with the official ISSN position stand, summarizing the key points. Can you walk us through those main takeaways?
Absolutely. The ISSN position, based on all this evidence, is explicitly stated as follows.
Creatine monohydrate is the most effective ergogenic nutritional supplement currently available for increasing high-intensity exercise capacity and lean body mass during training.
Okay, number one, it works for performance.
Number two, it is safe to consume and can have therapeutic benefits in both healthy and diseased populations, from infants to the elderly. There is no compelling scientific evidence that short or long-term use, up to 30 U-day for 5 years, has detrimental effects in generally healthy individuals or clinical populations.
Number two, it's safe with potential health benefits.
Number three, creatine supplementation is acceptable for use by children and adolescents who meet those criteria we discussed: supervised training, good diet, educated on use, proper dose. It may provide health and performance benefits and could be a safer alternative to anabolic drugs. Those label warnings about use under 18 are likely unnecessary from a scientific standpoint.
Number three, for young athletes under the right conditions.
Number four, creatine monohydrate remains the most extensively studied and clinically effective form of creatine available. Don't worry too much about the fancy alternatives.
4, stick with monohydrate.
5, adding carbohydrate or carb protein to creatine can help increase muscle uptake, but it doesn't necessarily enhance performance outcomes more than taking creatine monohydrate alone.
5, carbs help uptake, maybe not performance more.
6, the quickest way to increase muscle stores is the loading phase, about 0.3 GkJ for 5-7 days. But lower daily doses, 3 to 5 U/day, will also increase stores effectively over a longer period, 3 to 4 weeks.
6, loading is faster, maintenance works too.
7, even very high doses of creatine up to 0.8 GkJ, which is around 56 grams a day for a 70-kilogram person, have been used safely for years in clinical patient populations managing creatine deficiencies.
7, very high doses proven safe in clinical use.
And finally, number 8, more research is warranted to explore the potential medical and health benefits of creatine across a wider range of clinical conditions.
8, more research needed on medical uses. That's a really powerful summary, grounded in just so much research. It really highlights the gap between the scientific understanding and maybe the lingering myths or perceptions out there.
It absolutely does. It really drives home the point that you need to look at the rigorous, cumulative scientific evidence, not just isolated anecdotes or outdated information.
So this deep dive into the ISSN review really paints a clear picture. Creatine isn't just some niche bodybuilding supplement. It's an incredibly well-researched compound. It's highly effective for performance, yes, but it also has this surprising range of potential health benefits throughout life in different conditions. And all of this is supported by a safety profile that's remarkably strong, established over decades and thousands of studies.
It really underscores why we need to base our understanding of nutritional aids on robust science.
What's truly fascinating, I think, is how this one relatively simple molecule, something fundamental to how our cells manage energy, has such broad implications, from potentially protecting the brain of a newborn to helping an older person maintain muscle and stay independent.
It's quite remarkable, isn't it?
It really is. And it leads to a provocative thought, maybe. Given this documented safety record and the wide-ranging potential benefits for performance, for health, across the lifespan, should ensuring adequate creatine intake, maybe that baseline 3 to 5 grams a day the review mentions for maintenance or general health, become a more widely considered nutritional strategy for overall well-being, not just for athletes?
That's certainly something to think about based on the breadth of evidence presented here.
It definitely makes you reconsider the science behind the supplements you might see or hear about every day. And that's our deep dive for today.